Now, I want to remind you guys of something that we talked about last week. So last week we looked at graphs, and I'm going to pull up this file that I went over last week because I want to go over a few important things just to regurgitate your memory before we get into more details with acceleration on today. So, okay, give me just a second, guys, while I get this file pulled up. Okay, so hopefully you guys can see my screen here. One of the things that I discussed on last week is that I mentioned that typically whenever I introduce this topic of graphing, what I would do with students, I would go out to the football field and I would get three main volunteers. I would get a walker, a runner, and someone who would walk the field in the opposite direction. And then everyone else would have their stopwatches on their cell phones off to the side here, basically clocking the time for each of those individuals to reach their positions. So, assuming this is the 0 yard line here, and this is like the ideal 100 yard line over here, we will have our three volunteers. One would start over here, and they would walk from 0 to 100, and then we had another person to start over here, and they would run from 0 to 100, and then our third and final volunteer, he would start from here and he would walk in the opposite direction. He would go from 100 all the way to 0. And then once we collected the data as a class, here's an example of how that data should look like. And again, this is actual data from my 8th period class last year. Again, you see a walker, you see a runner, and you see data for someone who walked the field in the opposite direction. And of course, when we plotted out the data and we got best fit lines, this is what our best fit lines look like. Remember, we're plotting position along the y-axis and we're plotting time along the x-axis. Okay, and notice, guys, we have three different lines representing our three different volunteers. Does anyone know which of these three lines represents my runner? The line in green, the line in red, or the line in blue? Could someone tell me? Unmute themselves and tell me. Which one represents my runner? So if you guys remember, it was the line in green that represented my runner. We know that because the steeper the slope, the faster the object is moving. And so since the line in green is clearly steeper than the line in red, this object is moving faster. So this represented my runner, and this represented my walker. This individual in blue represented the person who walked the field in the opposite direction. Okay, so and remember, all of these individuals are moving at a constant velocity, or for the most part, a near constant velocity. And we know that because on the position time graphs, the lines are straight. If the lines were curved, that would indicate an object that is accelerating, and that is going to be the focus on today. Um, um, Thank you, Tranisha. I didn't see your chat at first. I didn't see what you put in chat about first. Whenever I'm sharing the screen, I can't see the chat, and since I can't get in Zoom right now on my other computer, I'm not able to see it. But yes, the green line, exactly. So the goal of today is to talk more about objects that are accelerating. Now, I'm going to go over a lot of rules for today. It's going to be a lot. Just bear with me. I do have everything that I'm talking about today. I do have posted in Schoology for you all. In the coming days, I will even put a PowerPoint of the different types of graphs and their descriptions. So just kind of bear with me as I go through all these rules. Like I said, typically in the past, I would prefer that you guys actually graph this stuff out yourselves. But, due to this current situation, I'm just going to go over the basic trends that you guys need to know whenever you are looking at a position versus time graph or a velocity versus time graph. So let me get ready to share my screen here. Okay, so if you guys can see my screen here, these notes here, these important notes, I actually have uploaded into Schoology right now, and you can even use these to do your Ed Puzzle assignment later on today. But basically, so whenever we're looking at a position time graph, and we want to be able to use that position time graph to be able to describe motion of a moving object, these are the specific trends you need to look for. And of course, as soon as we get done talking about position versus time graphs, we're going to talk about the important trends to look for in velocity versus time graphs. Okay, so even before we begin looking at specific examples, let's just read what I have here. So when you're given a position versus time graph, the first thing that you want to ask yourself, this is one of the most important things you want to ask yourself. You want to ask yourself, well, what is the overall trend of the function? Does it appear to be going downhill or uphill? Okay, I'm telling you guys right now, if you look at a position time graph, if it appears to be going uphill, that means the object is moving in the positive direction. If it appears to be going downhill, that means the object is moving in the negative direction. And we already talked about this last week. So uphill indicates an object that has a positive velocity, and downhill indicates an object that has a negative velocity. So that's the first thing you want to ask yourself. The second thing you want to ask yourself, does the slope have a curve? And if so, does the slope get flatter with time or does it get steeper with time? Okay, so guys, as a general rule, whenever you're looking at a position versus time graph, if the slope gets flatter with time, that means the object is slowing down. If the slope gets steeper with time, that means the object is speeding up. So another way of saying that, if you're going from steep to flat, that always indicates an object that is slowing down. If you're moving from flat to steep, then that always indicates an object that is speeding up. And in just a moment, we're going to see a specific example of what I'm talking about here. So as I share my screen here with you guys, so here we have a motion map. Hopefully, can you, guys? Okay, so here we have a motion map, and this motion map is showing us two things. Okay, it's showing us an object that's moving in the negative direction, and we also see an object that is clearly speeding up. Okay, so y'all notice that we're moving in the negative direction. So in other words, we have a negative velocity and we're speeding up. So how do we recognize those two important things on a position versus time graph? Well, the position versus time graph for this situation looks something like this. Let me go ahead and pull this up. So, this is how your position time graph should look like for that situation that we just looked at. So I want you guys to notice something here. So as we read our graph from left to right, what is the basic trend? Does it appear to be going downhill or does it appear to be going uphill? Well, if y'all notice, it's going downhill. So guys, anytime you see a position versus time graph, on a position versus time graph, a graph that is always going downhill indicates an object that is moving in the negative direction. So we can look at this graph, but because it's going downhill, we know that it's depicting an object traveling in the negative direction. But how do we know that we're speeding up on this position versus time graph? Well, guys, look at the slope here. Remember what I said, if the slope goes from flat to steep, that means the object must be speeding up. And if you notice, if I draw like a trend line somewhere around 1 second here, you notice that trend line appears relatively flat. And I keep drawing more and more trend lines at 2 seconds, 3 seconds, 4 seconds, and 5 seconds. If you notice, it gets steeper with time. So that trend line, basically, I just drew a trend line, which just it gave me an idea of what's happening near that point each second. So 1 second, 2 seconds, 3 seconds. If you notice the curve moving from flat to steep, that always indicates an object speeding up. I'm gonna say that again. If you notice a curve moving from flat to steep, always indicates an object speeding up. So we're getting steeper with time. So we will say this position time graph shows us an object that is speeding up in the negative direction. Okay, so let's look at some more examples. What about this right here? Okay, let me... So guys, for this particular motion map here, you guys should notice two things. One, it's moving in the positive direction and it's speeding up. Okay, so it's speeding up while moving in the positive direction. So that means when we look at our position time graph for this particular situation, we better notice two main things. Okay, we want to see an object that's basically, we want to see a trend, which is basically going uphill, right? Because going uphill means moving in the positive direction. And we also want to see a trend that's becoming steeper with time. So we want to see a curve that's becoming steeper with time. So how does this look like on a position versus time graph? Again, so on the test this Friday, I could give you guys various scenarios and ask you to correctly label which is which. So we're just going over those now. So on a position versus time graph, the scenario that I just showed you guys will look something like this. Okay. So what I'm showing you guys right now is the position versus time graph for it's the position versus time graph for what I just showed you guys. And notice the basic trend. One, we can clearly see that we're going uphill, right? As we read our graph from left to right, we're going uphill. So that indicates an object that is moving in the positive direction. How do we know that we're, for the most part, we're speeding up? Well, if you notice, if I draw a trend line somewhere around 1 second, it looks like the trend line right here tends to be pretty flat. But as I keep going, it gets steeper and steeper and steeper. Okay. So because we're going from flat to steep, we're clearly speeding up. So we're going from flat to steep, so we're clearly speeding up. So this object is speeding up while moving in the positive direction. Okay, let's keep going. Let's just keep looking at more examples. The more examples we look at, the better. What about this right here? So I want you guys to look at this motion map here. As you guys look at this motion map, you should notice two things. The first thing you should notice, sorry guys, I got an important message from a professor that I was looking at. Anyway, the first thing you should notice is that we're moving toward the left. Okay, so we're moving toward the left, which means we're moving in the negative direction. The second thing you would notice is that this object is slowing down. This car is, while it's moving in the negative direction, is clearly slowing down. So, on a position versus time graph, we better notice two things about this object's motion. Okay, so the two things we should notice is that the curve should be going downhill, okay, because it's moving in the negative direction. So, and not only should the curve should be going downhill, we should also notice that the curve should be getting flatter with time. Remember what I said, guys, anytime you're slowing down, the curve gets flatter with time. Anytime you're speeding up, the curve gets steeper with time. Okay, so how would this look like here? Okay, so on a position versus time graph, this should look like this. That is a situation that we just watched. Okay, so that situation that we just watched, guys, should look something like this on a position versus time graph. So, guys, anytime you see this on the test, how do you know this represents an object that is slowing down while moving in the negative direction? Well, the first thing you notice as you read your graph from left to right, notice the curve appears to be going downhill. Remember, if the trend is generally going downhill, that always indicates an object moving in the negative direction. Okay. The second thing you want to notice that as you proceed in time, the curve gets flatter. So as the curve gets flatter and flatter and flatter, that always indicates an object that is slowing down. And you guys should be able to see that here. So if I draw a trend line near 1 second, notice that trend line starts off, relatively steep, but as I keep going, if I draw a trend line at 2 seconds, and at 3 seconds, and 4 seconds, as you notice, it flattens out. So the curve is clearly going from steep to flat. So as we're getting flatter with time, that always indicates an object that is slowing down. So every time you guys see a position time graph that looks something like this, you should be able to look at that and say, that position time graph represents an object that is slowing down while moving in the negative direction. Okay. Let's look at one more major example for these position versus time graphs. So what about this situation right here? So if you guys look at this motion map, you guys should notice two main things. One, our car is moving in the positive direction. And two, our car is slowing down. Okay, so those are the two most important things you should notice. So that means whenever I'm finding a position time graph for this exact same scenario, there's two main trends I need to be looking for on my graph. Obviously, since I'm slowing down, there's going to be curves, but there's two main trends I need to notice in the curve. One, since I'm moving in the positive direction, that curve better be going uphill. The second thing I want to notice, since I'm slowing down, that curve better be flattening out with time. So with that stated, this is how this curve will look like on a position versus time graph. So this position versus time graph that I'm showing on the screen depicts that motion map that I just showed you all. Okay. So guys, on the test, anytime you see a general graph that looks something like this, You guys should be able to look at that graph and say, okay, I know what's happening there. That represents an object that is moving in the positive direction and slowing down. How do we know we're moving in the positive direction? Remember, as you read your graph from left to right, it appears to be going uphill. If the curve appears to be going uphill, that always indicates a positive direction of travel. Now, I want you guys to notice something else about the curve. Is it getting flatter with time, or is it getting steeper with time? So if you guys should notice, this is clearly flattening out with time, because if I draw a trend line at 1 second, notice that trend line appears to be relatively steep, and I keep going. I draw a trend line at 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. Notice that trend line tends to flatten out. So here, over here, that trend line is nearly vertical, but here it's nearly horizontal. So it flattened out. So if you're going from a trend line that is steep to flat, that always indicates an object that is slowing down. By the way, just a little side note for any of you guys that may decide to take calculus in the future, or you're currently taking calculus right now, the name of this trend line, which is basically a line that touches the curve at only one point. In calculus, we call that a tangent line. And the tangent line just indicates the slope of the curve at that point. And that's just kind of more of a calculus term that you guys will see whenever you guys have Beck Smith. So just something to keep in mind. Okay, guys, before we move on to the velocity time graphs, are there any questions? Anyone have any questions on position versus time graphs? Okay, so if there are no more questions, I'm just going to remind you, let me put back on the screen the most important things you're looking for. Okay. Okay, so remember, whenever you're looking at position versus time graphs, these are two most important things you want to ask yourself. You want to ask yourself, okay, does the graph appear to be going downhill or uphill? Okay, so what's happening to the trend? Remember, uphill means an object that is traveling in the positive direction. Downhill means the object is traveling in the negative direction. So in other words, uphill indicates a positive, uphill indicates a positive velocity. Downhill indicates a negative velocity. Okay. The second thing you want to look for whenever you're looking at position versus time graphs, you want to look at, does the slope have a curve? And if it has a curve, does the slope get flatter with time, or does it get steeper with time? Remember, for a curve that's getting flatter with time, if you see that on a position versus time graph, that always indicates an object that is slowing down. For a curve that is getting steeper with time, that always indicates an object that is speeding up. If you see no curvature at all, so just a straight sloping line, and that always means an object that is moving at a constant velocity. Okay, so just something to keep in mind. Any questions on position versus time graphs? Okay, let me stop, see if there's anything in the chat here. Any questions for me? Everybody think they got it? Okay, we're going to close out the day talking about velocity versus time graphs. And so let us go over the rules for analyzing velocity versus time graphs. Sky, there goes the attendance for you. Okay, so now that we've discussed position versus time graphs in some detail, let us look at more velocity versus time graphs. So, whenever you're looking at a velocity versus time graph, there are two important questions you want to ask yourself. You want to ask yourself, Does the line appear on the positive side or does it appear on the negative side? Here's why that's important, because if you look at the graph and you notice if you see a line or some sort of function appearing on the top half, which is the positive side, that always indicates the object is moving in the positive direction. If you see a line appearing on the bottom half, which is the negative side, that always indicates an object that is moving in the negative direction. So again, top half, the object has a positive velocity. The bottom half, that means the object has a negative velocity. Okay. The second thing you want to look for, you want to look at the function's trend. Does it approach zero with time, or is it going further away from zero with time? In other words, does it approach the x-axis, or is it going further away from the x-axis? So guys, as a general rule, if your line approaches zero, then that always indicates an object that is slowing down. If your line is going further away from zero with time, then that always indicates an object that is speeding up. I'm going to say that again. If you see a velocity versus time graph, and again, these rules are different from position versus time graphs. When you're looking for a velocity versus time graph, you want to see, okay, is it approaching zero with time, or is it going further away from zero with time? If it approaches zero with time, that means the object is slowing down. If it's going further from zero with time, that indicates an object that is speeding up. So let's just look at some examples of everything that I just said. Okay. So let me pull up. Guys, give me just a second while I pull up these plane graphs. Okay. No, that's not what I wanted. Hold on, guys. Pull up the wrong file. Give me just a second. Make sure I pull up the right. Why are these annotations still on the screen? Oh, guys, give me just a second while I delete some things. I'm clearing the answers from my previous class before I show you guys this file, so just give me just a second. Okay, I'm ready now. All right. Okay, so hopefully everybody can see this here. Okay, so guys, whenever you see a velocity versus time graph, your velocity versus time graph is going to always look something like this. Basically, you're going to have two halves. You're going to have a top half, which is positive, and you're going to have a bottom half that's negative. So, right, basically everything above the horizontal axis represents a positive velocity. Everything below the horizontal axis represents a negative velocity. Okay. So, last time I gave you guys this example here. So I said, suppose you have an object that looks like this. Uh, a velocity versus time graph that looks like this. Uh, what does this right here mean? Does anyone remember? Well, if you guys remember, this here represents an object that is moving at a constant velocity. To be specific, it's moving at a constant velocity of 2 meters per second in the positive direction. And so how do I know this velocity just stays constant? Well, because as time passes by, the velocity doesn't change. Okay. But what if I gave you guys something that looks like this? What if I gave you a velocity time graph that looks like this? Let's look at another example. What if I gave you a velocity time graph that looks something like this? What is happening there? Okay. So, guys, I'm telling you guys right now, this line here that I just drew represents an object that is slowing down while moving in the positive direction. How do I know this object is moving in the positive direction? Because notice I drew the line on the top half of my graph. If I drew this same line on the bottom half of my graph, that would indicate an object moving in the negative direction. But remember, if it's on the top half, that indicates an object moving in the positive direction. So here we're moving in the positive direction. And how do I know I'm slowing down? Well, remember, guys, I said if your line approaches zero with time, that means the object is slowing down, right? Because everything in this middle here, this horizontal axis, everything along this line represents zero velocity in the middle. So this is your x-axis represents zero velocity. So if you notice, as you read your graph from left to right, the velocity starts off high and then approaches zero. So if it's approaching zero with time, that means our object is slowing down. Okay. So this object here is slowing down while moving in the positive direction. Let us look at another example. What if I was to give you guys a velocity versus time graph that looks something like this? So if I give you a velocity time graph that looks something like this, what's happening there? So here, this object is speeding up. It's speeding up while moving in the negative direction. Here's how you know that. You know it's moving in the negative direction because if you notice, I drew my line on the bottom half. See, these are all negative velocities here. So it has a negative velocity. How do I know it's speeding up? Well, guys, if I move from left to right, if you notice, the trend line is going further away from zero. It's going further away from zero with time. So that indicates an object that is speeding up. Here's another example, guys. What if you see a velocity versus time graph that looks something like this? What does that mean? Well, you guys should be able to look at that and notice two things. The first thing you should notice, we're on the bottom half. So this is we're on the bottom half. We're still moving in the negative direction. So we have a negative velocity. And the second thing you guys should notice, we're slowing down. How do we know we're slowing down? Because we're getting closer to zero with time. Remember, as your line approaches zero, that always indicates an object that is slowing down. So we will say this object here is slowing down while moving in the negative direction. Let's look at some more examples. What if I was to give you guys a velocity versus time graph that looks something like this? What's happening there? two things you should notice, guys. I drew my line on the top half. So clearly I have a positive velocity. I'm moving in the positive direction. If you notice, as I read my graph from left to right, I'm going further away from zero. So if I'm going further away from zero with time, that clearly indicates an object that is speeding up. So here, this object is speeding up while moving in the positive direction. So you guys got that? So the line in blue here, the line in blue represents an object slowing down in the positive direction. The line in black represents an object speeding up while moving in the positive direction. So hopefully you guys can see the difference there. Okay. Any questions on velocity versus time graphs? Oh, and remember, guys, I said this last time. Anytime you have a velocity versus time graph, it looks like this. So if I have a velocity versus time graph, it looks like this. What does that mean there? Well, hopefully you guys remember that means your object is at rest. So we're at rest. So we're moving with zero velocity because it's going through the zero axis. It's going through the horizontal axis. Okay. Now, one more thing that I want to say, guys, before we close out this class. Here's a really easy way for you guys to remember speeding up or slowing down on a velocity versus time graph. Here's an easy way to remember that. So remember what I said. A trend that's going further away from zero always means speeding up. A trend getting closer to zero always means slowing down. Here's a really good way to remember that. Guys, in order to remember that basic rule, just think of a speedometer. Okay. So just think of a speedometer. Why is this? Hold on, guys. Let me. So, guys, if you think of a speedometer, guys, imagine you get in your car and you're driving. If you're driving and you decide to speed up, in other words, you press down hard on your accelerator. What do you guys notice about your speedometer? Your speedometer goes further away from zero as you're speeding up. Okay. Now, what happens the moment you slam your brakes? So the moment you slam on your brakes, then your speedometer, it goes closer to zero. Okay. So that's a really easy way to remember velocity versus time graph. So that's what a speedometer measures. Your speedometer measures your instantaneous velocity at any point. So use this example here to help you remember the rules for velocity versus time graph. Remember, anything going further away from zero means speeding up. Anything getting closer to zero always means slowing down. Okay? So this is just a general rule I need for you guys to remember. Okay. Any questions before I let you all go? Sometime later on today, I'm going to post a video for you guys to watch and answer the questions. I don't know if I'm going to be able to do it right now because I got to get ready for my next class. But
Taylor,
yes.
is there a way like you could email it to us because our lunch pad isn't working and I tried to log into Schoology just like without going through the lunch pad, but we still have to log into the lunch pad to get to it.
Okay. You know what? You are right because I just realized I was having problems with Launchpad earlier. If see, the problem is it's going to be hard for me to it's going to be hard. I don't know everybody's email address and sending that out to everyone. I tell you what, if Launchpad is not working by noon, you guys don't have an assignment. Okay.
Okay, also you have a message in the chat.
Okay. Tim, I'll look at that and I'll send you an email back when I get to it. Okay, yeah. If Launchpad is not working by noon, then don't worry about it. Okay. Hopefully
Okay,
Launchpad.
thank you.
I tell you what. Let's give it to 1 o'clock. If Launchpad isn't open by 1 o'clock, then you guys will be good for today. Okay.
Okay.
All right. Y'all have a good one. Okay. Thank you for letting me know that.
You have a good one.
You
Bye.
too. Bye, Samaya. Tim, I'm gonna check and I'm gonna get back with you.